Good day, and thank you for joining me for this presentation. I want to have a talk about data, but more specifically, how data has been transferred throughout the years. This is what we will focus on today. There is usually a misconception about these three: data, information, and communication. Data is a collection of facts for reference and analysis, whereas information is the knowledge gained after analyzing the data. Then finally, once that information has been gathered, communication is the transfer of information from one point or person to another. I will just quickly touch on data analysis. This is the step in the chain that produces the information. Data analysis is the detailed examination of the elements or structure of something. Some basic data analysis includes graphs and dashboards. I'm going to use the analogy of a wall. Think of our data as the building blocks to a wall. The analysis is the cement that holds these blocks together to form the sturdy structure, or information wall. Who uses data? In the meteorology and hydrology sectors, apart from the delivery of daily weather conditions, it is also used in disaster risk reduction. In agriculture, data is used to ensure that crop yields are at optimum levels. For example, when to irrigate or not. In the health sector, data gathered can inform if the dust levels will be significantly high to affect persons with respiratory issues. Data is also a key component in numerical analysis, or models. Good quality data is needed and lends to the enhanced communication of that information. So, how do we go about collecting this data? We are going to look at some data transfer methods and weigh the pros and cons. Manual collection. Observers go into a station to collect data. For example, observational plot. They would usually take a pen and paper. This is how it was done, and it's tried and tested, and it's reliable. However, data collection is slow and labor intensive, and it's usually done at fixed intervals. Manufacturers have allowed for data downloads to be dumped straight onto flash storage devices. For example, USB or SD cards. They also have the ability to store data on portable devices, download from multiple stations. You can then take it back to the office for analysis. This is more efficient in terms of large data collection periods. Once downloaded, you essentially have copies of the data. However, additional peripherals are now required and possibly they can be corrupted. Laptops. This lends for direct downloads from stations and also in-field processing, basic analysis of data where you can determine if you have good quality data. However, this is a very costly peripheral. Wire transfers. This is a direct connection to data collection devices to transfer data. Some transfer types include RS-232, RS-485, and coupled with line drivers and range extenders, these can be very inexpensive peripherals and they're usually plug and play. However, trenching costs can be high as these wires are usually underground and as a result are susceptible to electrical discharges. Satellite communication. Data is sent up to a geostationary satellite, for example, NOAA NESDIS and Iridium. This lends for very remote sites to be installed. Hourly slots are usually allocated. Communication is one way, and in the case of Iridium, data transfers can be relatively expensive. Wireless cellular. Manufacturers have incorporated cellular data modems in their data collection platforms. For example, TDMA, which stands for Time Division Multiple Access, was the standard used a long time ago. That has now been replaced by GPRS, or General Packet Radio Service, which brings us 3G, 4G, LTE, and 5G. This allows for a remote site to be installed and near real-time communication. However, once again, you're dependent upon ISP coverage. You have recurring data charges and communication is one way. Wireless. With the advancement in technologies, short and long range transfers are now possible. Manufacturers making use of open band frequencies for off-the-shelf solutions, for example 300 MHz, 433 MHz, or 2.4 GHz. Multiple data collection points can be installed to produce a network of stations to communicate back to a base station. This lends for greater efficiency of coverage of areas. However, depending on the terrain, implementing this type of network can be costly. And where open bands cannot be used, licensing of desired frequency is required. The Internet. Internet provides data transfer protocols, for example, HTTP, FTP, TCP. These are very fast data transfer rates and can provide us with real-time communication. However, once again, you're dependent upon your ISP uptime and you have recurring usage fees, usually every month. The Internet of Things. This is usually associated with smart home devices. Manufacturers have coupled wired or wireless capable devices to use this protocol to pass data directly from the field to any device that is listening. Two common Internet of Things protocols are the MQTT, which stands for Message Queuing Telemetry, and the ZigBee. Although it's a recent protocol, it's rather widely used and the ease of implementation is rather straightforward. However, some intermediate level programming is needed, especially at the client side. Data storage methods, text files, notepads, and Excel. Ease of access, ease of storage. However, these types of storage are relatively slow in retrieval of data, and you have a limit to your data storage. Database management systems, for example, relational databases, where data is placed in structured tables, where you can use the structured query language or SQL to get that data from the database. Some popular relational databases are SQLite, MySQL, and Postgres. Then we have non-relational databases or NoSQL databases. Storage using non-table structure methods, and this is usually linked to big data. Two common non-relational databases are MongoDB and FirebaseDB. Time series databases. These use a quasi-table structure and is geared towards optimization of time series data. And these are commonly used with dashboards. These allow for quick access times of your data and you're also able to do some pre-processing of your data sets, and it's scalable. However, intermediate level of programming is needed, and you have some additional hardware requirements. Here we have a data retrieval scenario. We have a user desirous of data collection from a server, and that server sits with access to the internet. So the user then connects to that server, usually through an API or application processing interface. The API speaks directly to the server and then makes that data available once again through the internet to the user. This interaction is done in a matter of seconds. Data visualization methods. We have three mapping utilities here: GNUplot, Matplotlib, and Seaborn, and a dashboard utility, Grafana. In conclusion, data transfers have come a long way from the basic pen and paper to being beamed to geostationary satellites. Ultimately, good quality data is the backbone of a wide range of sectors. As the world advances, so too the innovation related to data transfers and analysis techniques, which will ultimately lead to better communication. Thank you.